Today I'm going to share with you Leetcode 1448, count good nodes in binary tree. This is one of Leetcode 75 study plan problems. So it says return number of good nodes in the binary tree, and a node is good if in the path from root to x there are no nodes with a value greater than x. What if there is some node whose value is equal to x? Then x is still a good node, right? So generally in a tree problem, think from a middle state, which means imagine yourself, you are some node in between, not the root, not the leaf, but in between. So imagine you're 4. How do you know you're a good node? You know it because the maximum value from root to you is 3. And 3 is smaller than you, so you're a good node. And do you care about what happens below you? Not necessarily, right? But what you do need to do is, after your turn in this level in a recursive function, you have to tell your children who is the greatest value before you see your children. So now our logic is clear. Imagine you're at 4. What do you want from your parent? You want it to tell you the largest value it has seen among all of your predecessors before it reaches your level in a recursive function. You cannot get away with recursive function in this question. And similarly, the same rule will apply to you. So before you reach 1 and 5, you need to tell them what is the maximum value you have seen so far, including your level. That way, your children could compare their values to the maximum you give to them, so they could tell if they're good, right? And what do you need from your children? Nothing. Not necessarily. You don't care what happens below you. So private. Remember, what you're going to give to your parent will be your return type. And in this case, we've said we do not need to give anything to our parent. So this is void here. And traverse. Of course, we're going to traverse on node. I'm going to name it node. And what you're going to give to your children will be in your arguments. So in this parenthesis, we need to give int max, which is the maximum value you have seen so far. And in most of the cases in tree problems, base case check will be if node is equal to null, you return. I'm not saying for all, but most of them. So, and I think it's pretty straightforward that in this problem, we're going to do a pre-order check. This is 3, 1, 3, 4, 1, 5, right? You cannot do post order because post order is from bottom to up. And so, we're going to do something with current node. And after that, we're going to traverse. Traverse left and traverse right. Okay, so here I'm going to do a comparison. Then I'm going to check if I need to update max. And when I'm counting number of good nodes, I would need a class variable, count, initialize it in this function count equals 0, call traverse function, gives root, and in this case, if you're at 3, then the maximum value will be 3, right? So it's root.value, and you return count. So, comparison, count plus equals what? We need to compare, we need to ask the question, is max greater than node.value? If it's greater than node.value, then count will not change, which means count plus equals 0. Otherwise, we're going to plus equals 1. And now we need to update a max. Max equals math.max. Compare yourself with max. If you are greater than max, then you become the next max for your children. So it's node.value max. Yep, and this is how you solve this problem.